Let's say for a chemical reaction A plus B, a student wants to figure out after how long the compound R will be forming. For this, TLC is one of the most inexpensive way of doing this. The student will have to put up multiple TLC plates at different times of the reaction. Let's say at time 0, when the student has put A and B in the reaction pot, she immediately dips her TLC capillary in the reaction pot and takes out a little bit of sample R and spots it on the TLC plate. She will also have to put the authentic A, authentic B, and then when she will run or develop this TLC plate, she will see under the UV light that the first spot of R matches the authentic A. The second spot from the sample R matches with sample B, which is very normal because the reaction has not yet started. So from this kind of a TLC plate, you are given this and you are asked, there are two things that you can figure out. Either the reaction has not started or the reaction is not going on. So depending on the choices that you will be given, you have to choose the correct one. Look at the RF values here. The RF value of sample A and the first spot's RF value are very similar. And this is where the identity part of the TLC comes into play. After 20 minutes, the student again takes a fresh TLC plate. She spots authentic A, authentic B, and the reaction mixture after 20 minutes of the reaction time. She dips her TLC capillary, a fresh TLC capillary, into the reaction mixture, takes out a little bit of sample, spots it on the reaction plate, and then on the TLC plate, and then runs or develops the TLC plate. Always remember to leave a little bit of dry space up here. And when you take the TLC plate out, always mark with your pencil so that you would know where the solvent front is. On observing this TLC plate 2 under the UV light, the student sees that there are 3 spots on her reaction mixture sample. The reaction or the spot 1 is definitely the compound A because of the similar RF value. The spot 2 is definitely sample B because of its similar value. But what is this new spot 3 that we see? It is clearly an indication that a new compound has started to form in this particular reaction. Has this reaction completely done? We do not know that yet. So we cannot make a firm judgment based solely on this. So she decides to let the reaction go for some more time. So after the 40 minutes of her reaction being started, she takes a fresh plate, spots A, B, and the reaction sample R after 40 minutes. And she still sees that the 3 spots are still there. What do we conclude from plate 2 and plate 3? Definitely a new product is forming. The starting materials are still there. And no change has been observed from plate 2 to plate 3. At this point, her professor or instructor steps in and her instructor tells her to keep on going for some more time and observe. And she, being a good student, listens to her instructor and waits for a little longer. So at time 60 minutes, 60 minutes from the beginning of the reaction. She takes a fourth fresh plate, marks authentic A, B, and R. So this is the reaction sample after 60 minutes of the reaction. What does she observe now? She observes that instead of having the 3 spots which she saw earlier in the lane of reaction mixture R, now there are only 2 spots left. What can you conclude from plate 4? If you observe the number 1 spot and the RF of compound A are very similar. The compound B is no more present in the TLC plate. You have a second spot, which is a newer spot. It did not match A, it did not match B. It is a new spot, which is probably the reaction mixture. The question here is, can this reaction go any more in the further direction? Do you think she should wait for a little longer to take this reaction down, or she can just stop the reaction at this point? Thinking about this, since one of your starting materials is gone, compound A cannot generate compound R on its own. So the compound B is your limiting agent, whereas your compound A is the excess reagent. When you have this mixture, and this is an impure mixture, why? Because you have more than 1 spot on your TLC plate in this sample. Let's say that you put the reaction mixture sample on your column chromatography column. Because the TLC plate has the tendency to put the non-polar items or the non-polar compounds will elute first. In the same manner, the column also knows that the non-polar compounds will elute first. So it is just the reverse. For capillary action on TLC plate, the non-polar compounds rise. Because of gravity in the column, the non-polar compounds elute first.